Okay, in this stats video, we're going to cover 2.1, I guess you can call it part 1. We're going to do the 2 top learning objectives, which is find and interpret the percentile of an individual value within a distribution of data, and then estimate percentiles and individual values using a cumulative relative frequency graph, which is kind of a mouthful, but yeah. All right, so these two. Now, in percentiles, we have, it's kind of it's kind of an easy one to do, so we'll see how it goes. So one way to describe the location of a value in a distribution is to tell what percent of observations are less than it. Okay, that's your key right there, less than it. We have the p percentile of a distribution is the value of p% of the observations that are less than it. Again, all right, we're going to stick with the less than it part. So, for example, we have a 25 data scores from tests, right? We just made up some numbers. And Jenny earned an 86 on her test, right? So she's at 86. So she's right here. This is Jenny. Right? How does she perform relative to the rest of the class? So you're thinking to yourself, okay, she got a B, B plus, no, she got a B, right? But how well did she do based on the rest of the class? Because a B isn't really going to tell you how many people got above her, how many people got below her. And then by the looks of it, it looks like she scored pretty well because it looks like she's only 4th from the top, right? And a bunch of people scored below her. The only question is, what percentile is she at? 86 on a score doesn't really mean she's at the 86th percentile. That just means that's her score of 86. So what we do is we count how many people are below her, and in this case, if you count all of these numbers here, she is the 22nd person. So 21 people scored below her score of 86. So if you take 21 of the people, right, and divide it by 25, you get 84%. So that means she is at the 84th percentile, right, for her class. All right, and you can do this with any of the others. You can say, okay, well, let's take the score of 72. This person who scored a 72, they weren't the last person, right? There was one person underneath them. Okay, so a score of 72 is at the, let's see, only one person scored lower than them, so 1 out of 25 would give me a score of, let's see, 1 divided by 25, 0 point, or is it 4%? Yeah, 4%. Okay, so it gives you a score of 4%. So the score of, gives you a percentile of 4%, I should say. So the score of 72 is at the 4th percentile. And obviously the person who got the last score of a 67, they were at the 0th percentile because no one scored less than them. And now the tricky part is the top person. This person, 93, right? The score of 93. Now, you would expect, since they were the top person, for them to be at the 100th percentile, but that's not necessarily true. 24 people are below them. So we're going to say 24 out of the 25, right? So 24 divided by 25 is at 0.96, which means a score of 93 is at the 96th percentile. All right. Even though they did get the top score, they really should be technically at the 100th percentile. But if we're going to use the definitions, percentile is the distribution of the value with p% of the observations less than it. 24 of the observations were less than the 25th one. So 24 out of 25 gives you 96%. Okay. All right. So those are percentiles. Now we move on to cumulative relative frequency graphs, which is a really mouthful, and I'm going to start to abbreviate probably as CRFGs if I really need to. Okay, so a cumulative relative frequency graph displays the cumulative okay, meaning the sum total, and the relative frequency you know how to do, all right? The cumulative is just going to be a little bit of a tweak on the relative frequency that you've usually done. So we have here age of the 44 presidents when they were inaugurated. So if you take the 2 plus the 7 plus 13 plus 12 plus 7 plus 3 should add up to 44, because we're going to have 44 presidents here. So the relative frequency you know how to do. We've taken it many, many times. You take the 2 divided by 44, 7 divided by 44, 13 divided by 44, yada, yada, yada. You've done the percents before. Okay, now, cumulative frequency is kind of easy to do also, except you need the cumulative columns first, not the counts, the cumulative. So counts is already here. 2, 7, 13, 12, 7, 13, 7, 3. Those are your counts. 13 presidents were between the ages of 50 and 54 when they were inaugurated. 2 presidents were between the age of 40 and 44. But the cumulative counts, or I'm going to say cumulative frequency, are just a little bit different. And you're going to have to excuse my horrible lines, but so here's how cumulative works. Since we started with the 2, we don't have anything to add it to, so we're just going to put a 2 down, because 2 is what we're going to start with. Now, if you have 2, and you have 2 presidents, I'm going to add 7 more presidents, okay? I'm accumulating the presidents in numbers, so 2 and 7 should give you 9. I'm accumulating. If I have 9 presidents so far, then I'm going to add 13 more of them, then I should get 22 of them. I have 22 presidents so far. I'm adding 12 to my list. I should get 34 of them. I have 34 presidents so far. I'm adding 7 more presidents. I should get 41. And if I have 41 presidents, I add the last 3. I should get my total of 44 presidents. That's cumulative frequency. You're just keeping count day in and day out. You're just adding more to it. Now, cumulative frequency or relative frequency graphs come from taking the relative frequency of your cumulative frequency. I'm sorry, taking the you'll see in a second. God, it's a tongue twister. Okay, you had 2. Well, basically, you're just going to do the same thing you've done before. 2 out of 44, 9 out of 44, 22 out of 44. I have to do this on a slant because I'm running out of space. 34 out of 44, 41 out of 44, and then 44 out of 44. And the last one should be 100% because you have all of your presidents. 2 out of 44 should be, what was it, 4 point... where did it go? Oh, there it is. 4.5%. Somewhere around there. And then you can take the time and fill this in. Okay, now, these numbers here are graphed onto this graph over here. It's not linear, it's not a histogram, it's not a box plot, it's not anything. You're just literally just keeping track of the cumulative. And it should always be up to 100 if it's a cumulative relative, because at the last bit of information, you should have 100% of your individuals. In this case, 144 of our presidents out of 44 is 100%. So we typically start with 0 and then work our way up. Now, interpretation of this, because that's the whole point. Here's how we interpret this. If you say you're looking at someone who is inaugurated, and let's say they were 50 years old when they were inaugurated. Okay, I'm going to zoom in real quick. Let's say they were 50 years old when they were inaugurated. So if you look around here, you get to 20. And what it should mean to you, right, the 20, is that at the age of 50, if you're a president and you got inaugurated at the age of 50, so far out of the 44 presidents that we've had, this person is at the 20th percentile. So 20% of the rest of 20% of the presidents were younger than this person at the age of 50. Okay, and same thing again. So let's take this person at the age of, it looks like it's about 60. So at 60 years old, whatever president was inaugurated at somewhere between, I think we have 60 to 64, because that's our kind of our data range a little bit. If you look at the age of 60, right, and you go up, and then you go across, okay, let's say 75, right? So that means 75% of the presidents were inaugurated with an age less than 60. So they could have been they could have been anything less than 60 up to 40, because that's where we started. Okay, obviously they weren't 35. So that's what this is. Now, and then at 70, right? At 70 years old, 70 years old, if you were inaugurated at 70 years old, almost everybody was younger than you at that point. All right. So that's how you interpret the cumulative relative frequency. So I think there's an example here that we could do. Let's see. Was Barack Obama, who was first inaugurated at the age of 47, unusually young? So we can figure that out. So he's at the age of around 47. That's 45. So I'm going to say around 47, right? Let's say around somewhere there. And then we look across, and it's about 10%. So in answer to question A, Barack Obama, B-O, Barack Obama, at age 47, can I say was at the, I'm going to say, can I say he was at the 10th percentile? Let me just make sure if I can say that or not, because I don't want to mess you guys up. He's at the 11th percentile. Yeah, that works too. At age 47, that's a 4, sorry, is at the, I don't know, we can say the 10th percentile. Okay, so that means 10% of only 10% of the 44 presidents were younger than him. Okay. All right. So now the next question is estimate and interpret the 65th percentile of a distribution. So let's see, we can go over here. 65th would probably be, okay, so that's 70. This is probably about 65. We go across, and then we look down, and we see that it's about 50, what is that, 58? Let's say 58. Okay, so estimate and interpret the 65th percentile of distribution. So at the 65th percentile, a president is roughly around the age of 57 on the day of their inauguration. All right. I think that's okay. And then that means everybody, so at the 65th percentile, they were around 58 years old. And everybody, and 65% of the presidents were younger, so 65% of the presidents were younger than the age of 58. Okay, now, next part is for you guys to go to section 2.1, page 89, and answer the check for understanding questions 1 through 4, which look like this right here. Okay. 1 is in multiple choice. You don't have to copy the whole sentence down. Just give me A, B, C, D, or E. 2 goes with, it's standalone. Questions 3 and 4 are actually related to the graph over here. Estimating Q1, Q3, and IQR distribution. It shouldn't be too difficult to do, especially since this is the frequency, cumulative cumulative relative frequency. Do the best that you can with those three. And that should be it for this video.